And now we have examples part 1 in our discussion on temperature and heat. So first, we have sample problem number 1. Determine the temperature value at which the Celsius and Fahrenheit scales coincide, meaning Tc is equal to Tf. Determine the value of the temperature wherein Tc is equal to Tf. Tc is equal to Tf. Let them be just equal to temperature T. The conversion equation from Tc to Tf is given by Tf is equal to 9 pips Tc plus 32. Tc is equal to Tf is equal to T, so let's replace Tf by T and Tc by T. There's only one unknown now, T. Isolating T, we get T is equal to negative 530 times 32 divided by 4. That will give you negative 40. So T is equal to negative 40.000. At this value, Tc is equal to negative 40.000 degrees Celsius. If you convert that to Fahrenheit, Fahrenheit temperature Tf is also equal to negative 40.000. But this time, the unit is degrees Fahrenheit. Next, we have sample problem number 2. At 20 degrees Celsius, a brass cube has edge length of 25 centimeters. What is the increase in the surface area when it is heated from 20 degrees Celsius to 75 degrees Celsius? The coefficient of linear expansion of brass is given 19 times 10 to the negative 6 per Celsius degree. So initial edge length, the temperature changes from 20 degrees Celsius. At 20 degrees Celsius, the edge length is given. The temperature changes from 20 degrees Celsius to 75 degrees Celsius. So initial temperature T naught is 20 degrees Celsius. At temperature T naught, the edge length is 25 centimeters. So that's the initial length, initial edge length, L naught. Final temperature T is 75 degrees Celsius. And the coefficient of linear expansion of brass, alpha brass, is given 19 times 10 to the negative 6 per Celsius degree. We are being asked for the increase in the surface area. So change in surface area, delta A, we are looking for. There are a couple of ways of going about answering this problem. One is shown in this example. First, we take the change in temperature. Delta T is final minus initial temperature. So T minus T naught, that will give you 55 Celsius degree. Using this change in temperature, we determine the change in the edge length of the brass cube. Delta L is final length minus initial length, so L minus L naught. And delta L is equal to L naught alpha brass delta T. Change in length is equal to L naught alpha brass delta T. Transferring L naught to the other side, we get the equation for final length. Final length is L naught quantity times 1 plus alpha brass delta T. From geometry of cube, the surface area of a cube is area on one side times the number of sides. A cube has 6 sides. And the area of one side is area of a square. So that's just simply edge length squared. So initial area on one side is L naught squared. Total surface area is 6 times the area on one side. So A naught, initial surface area is 6 L naught squared. We know L naught, 25 centimeters. So we are able to calculate the initial surface area. 3,750.0 centimeter squared. Now, using our equation for final length, L is equal to L naught times 1 plus alpha brass delta T, we can get the value for the final area, final surface area. Just like with A naught is equal to 6L naught squared. Final area is equal to 6L squared, where L is the final edge length. And L is just equal to, again, equal to L naught times 1 plus alpha brass delta T. Don't forget the square because L squared. Plot in the values. We know L naught. We know alpha brass. And delta T, we know to be 55 Celsius degree. So, kumpleto. We are able to calculate the final area to be 3,757.841595 centimeter squared. Knowing the initial area, knowing the final area, we are able to get the change in area delta A rather. Delta A is just equal to final area minus initial area. So, A minus A naught, which will give you delta A is equal to 7.842 centimeter squared. In this example, we used linear expansion analysis combined with equations of area to do area expansion analysis. Another way of doing this is, first we calculate the initial area. Knowing the initial area, we can use the area expansion equation. Delta A is equal to A naught sigma times delta T. Sigma of brass, we can get from alpha brass. Sigma is just 2 alpha, so sigma brass is just 2 times alpha brass. We are able to get the delta A, which will also give you basically the same answer, 7.842 centimeter squared. And that's it for this video. That's it for this session. In the next video, we'll continue our discussion on temperature and heat. In the next video, we'll take a look at the concept of heat energy. So once again, that's it for now. And thank you for watching.